In this video, we're going to demonstrate how to do recode and replay of IBM MQ messages. So we're on the main documentation page. We're going to go to IBM MQ. And I encourage you to read through this whole documentation. But what we're going to start with right now is a hypothetical situation which you see in real life quite often, which is two systems, System A and System B, communicating with messages. System A is going to send request messages to a request queue, which are going to be consumed by System B. Then System B does some processing, responds with a response message to the response queue, and then System A consumes that response message. Okay? So to do a recording of those messages, what we're going to do is add two additional queues to the IBM broker, a virtual service request queue and response queue. And we're going to use the virtual service to record the mappings for us. So what you can see in this diagram is the white stuff, which is what you have seen in the previous diagram, and the blue stuff, which is the virtual service bit, the new bit. So System A communicates, sends a request message to the virtual service request queue, which is consumed by the virtual service, and then proxied, forwarded to the request queue, which is then consumed by System B. System B does some processing, responds with a response message to the real response queue, which is then consumed by the virtual service, which already has the request and the response, so that creates a mapping between the request and response and saves it in the mapping repository, and then forwards that same response message to the virtual service response queue, which is then consumed by System A. So this way, using those two additional queues, we were able to record the GMS messages, the IBM MQ messages. And now what we're going to do is scroll a bit down and show you the replay. So now what you want to do is replay those messages you have recorded and potentially change the contents of those messages. We're going to have a look at that as well. So in this case, the white stuff is what you have seen in the previous image, but you'll notice that there's no System B here. So we're going to be testing our System A system under test in isolation by using the virtual service that is going to pretend to be System B. And the way it happens is System A system under test will send a request message to the virtual service request queue, which is then consumed by the virtual service, and it will look for matches on the request message, find the response message created on the response queue, which is then consumed by system under test System A. This way we are able to test our System A system under test in isolation without having to rely on System B. Okay? So let's go ahead and look at this recording, and what we're going to do is use an IBM MQ broker, and what you can do is, let me show you this stuff. So you can use either of those two following. You can use a IBM MQ broker in one of your test environments that you already have, or alternatively you can use a developer edition of IBM MQ and run it using Docker, and the more information on that is available here on the Docker Hub in the IBM MQ for Developers section. And that's what I'm going to do. So I'm going to run a Docker and a Docker IBM MQ9 instance. So let me show you that. So I've got a terminal here, and if I list my running containers, you can see here I've got a IBM MQ9 running already. So on my laptop I've got an IBM MQ version 9 running in a Docker container. That's the developer edition. So we're going to use that as our broker, and then we need something to pretend to be System A and pretend to be System B. So in order to keep this demo nice and sweet and do not complicate it too much, what we're going to do is pretend to be System A and pretend to be System B using MQ Explorer. So we're not going to have those special systems, System A, System B. I'm just going to directly poke the messages, put them on the queues, and consume them from the queues using MQ Explorer. And what we're going to need in here as well is a view of the broker. So let's have a look at the broker. I've already connected to it, and you can see the queues in here. So there are some default queues from the IBM MQ Docker image, but we've got 4 queues set up here that I've added. It's the request and response queue, which you can see. The request and response queue, they're here. So these are the real queues used by system A and system B. And what we're going to have also is the virtual service request queue and virtual service response queue, which are TP request queue and TP response queue. Okay? So now what we want to do is set up this recording. So I need to start up the virtual service traffic parrot and point it at the right queues. But to do that, we need to first of all understand how to let traffic parrot connect to IBM MQ. And if you look at the documentation, there's a section here called required jars. And in this section, we describe what you need to do to allow traffic parrot to connect to IBM MQ. So to do that, you're going to have to follow the IBM MQ instructions, which are here. So I encourage you to read this carefully and obtain the jar files that are required and in the recommended way by IBM. I've already got the jar. I'll show you that in a second. And what we're going to have to do is copy those files to the special lib external directory in traffic parrot. So let's do that. So first of all, I'm going to open a terminal, and in that directory I've got traffic parrot, just downloaded it, and that IBM MQ jar file that we're going to need to copy to lib external. So first of all, let's unzip traffic parrot. There it is, it's been unzipped, and now we need to copy this jar file to traffic parrot lib external. Okay, so what we have done now is basically this section and allow traffic parrot to connect to MQ using the provided MQ jars. So what we can do now is go to traffic parrot and start it up. There it is, it's running. You can go to the UI and see that it's running. We can go straight into IBM MQ recording. And what we're going to do now is go back to the documentation and set up this recording scenario. So let's go ahead and do that. So I'm going to record the TP request queue, and if I scroll down a bit in here, this is where the diagram of the deployment diagram of the systems, how they communicate, is overlaid on the UI, so you can easily, map your brokers and queues to the UI. And one more thing, so what you can see here is that there's a drop down with a list of connections, and I'm going to use the local MQ9 connection, but you might want to define more connections in here, or a connection to your specific test instance MQ broker, for example, in your company. And in order to do that and add something to this drop down, what you're going to do is click this question mark, which is going to take you to this page, and there's the whole section that will tell you how to define new connections in this drop down. So it's pretty straightforward. There's a file in traffic parrot main directory called IBM MQ connections.json, and you just add your connections in there, and what's going to happen, they're going to appear in this drop down. It's pretty straightforward. But going back to our queues, so what we're going to do is record from the virtual service queue and virtual service request queue, and put those messages, forward them to the real request queue. So let's go ahead and do that. So record from the virtual service queue, request queue, and forward it to the real request queue. And when it comes to the responses, we're going to consume from the real response queue and forward them to the virtual service response queue. So let's go ahead and do that and turn it on. Okay, so we've got a recorder running. If I scroll down, you're gonna see the current recording session, the messages here. There's no messages yet. So right now what I'm gonna do is pretend to be system A and send some messages, send a message to the request queue. I send a request message. So I'm gonna do that I'm gonna pretend to be system A using MQ Explorer and send a message directly to the TP request QL. I'm gonna say it's request 1. Okay, so now what we expect to happen is that the virtual service has consumed that message and forwarded it to the real request queue. So first of all, let's look at the virtual service. And yeah, it's noticed this message, notice a message on the request queue, and the text of the message was request 1. And what else should have happened was that that message should have been forwarded to the real request queue, which is here. So let's browse those messages and look at that message. And yeah, there it is, message data request 1. So it has been forwarded by the virtual service to the real message queue. So what I'm going to do now is pretend to be system B and consume this message. So I'm going to consume this message by deleting it basically. So there it is, the request message has been consumed, and now I'm going to pretend to be system B again and produce something to the response queue. So let's put a message RSP1. Okay, so what I have done now is pretended to be system B and send a message to the response queue. So right now the virtual service should have consumed that message, created a mapping and forwarded that message to the virtual service response queue. Okay, so let's have a look at that. So first of all, did it consume that message and create the mapping? Yes, there is. There's a response message, and the text of the response is RSP1. And what we can see here also is a mapping. So it's recorded that if there is a message on the request queue and the request body is equal to RAQ1, then there should be it's going to put a message on the RSP queue, the response queue RSPQL, and the response text is going to be RSP1. Okay, and what should have happened next was, so we've just proven that the mapping has been recorded, but the message should have been forwarded to the response queue, the virtual service response queue. So let's have a look at that. And there is this queue, and the data is RSP1. Yeah, so let's pretend to be system A and consume this message by deleting it. Okay, so we've gone through this whole cycle and recorded a request and response message. We can turn off the recorder, and what we're left with is this mapping, which we can now replay. So let's have a look at the replay. I'm going to scroll a bit down. So this is the replay. So we're going to use the same two queues on the IBM MQ broker, but we're going to test our system under test in isolation. And virtual service, when it sees the request message, what it's going to do is look up the response and produce the response message. Okay, so let's go ahead and start the recording. Sorry, the replay. It's going to be a queue replay, and we're going to consume from local Docker MQ9 and produce responses to local Docker MQ9. Yes, that is correct. So turn that on. So now what we expect is that if I send something to the request QL, there's going to be a response produced on the RSPQL. Okay, so let's have a look at these queues right here. There's something here for some reason. Let me clear that. That's I forgot to consume that message. Ah no, that's not a message. Sorry, that's just the consumer. Yes, we're right, because it's the virtual service consumer right now listening on this queue, consuming from this queue. Okay, so let's put something on this queue. It's gonna be request 1. Put message, close. refresh. And there we go. There's a message on the response queue. Let's have a look at it. And it's RSP1, which is exactly what we expected. Okay? So let's consume that message, pretending to be system A. Okay. Good. So now what we can do is change that actual message. So instead of RSP1, let's say we want to change the response to be something else. We can also say that, for any request, it doesn't have to be request 1. There's many things you can match on here, really. You can change the queue name, you can match on the body, on many things. JSON and XML is probably what you're most often going to be matching on or contains. Let's actually make it equal to ABC, just for the purpose of the demo. So we need to send something to the queue, request QL, and it's supposed to be a request with that's equal to ABC, and the response text is going to be this. So turn that on, it's running, and now send ABC to this queue, and we expect something on the RSP queue. The data is RSP 1, 2, 3, 4, so exactly what we expected. Yep. We can pretend to be system A again and consume that by deleting it. Okay. So that's pretty much it. There are many other things you can do here. All you have to do is browse through the documentation, especially the extensions. There's a lot of things you can do here actually, and there are very powerful custom extensions you can use as well. So have a look at that. And so just to reiterate, what we have done was we're simulating this scenario where two systems are communicating with request and response messages in a real production environment, and what we have done was created two queues on the broker and use them to record the messages using a virtual service. And what we have done then was tested our system A under test. I was pretending to be system A by using MQ Explorer, and we tested it in isolation by using the traffic that we've recorded. So the virtual service consumed the request from the request message from the request queue, matched something in the from the mappings repository, and produced a response message that is recorded earlier to the response queue. Okay. So thanks for watching, and hope to hear from you soon.